Okay, let's go ahead and start off with a little bit of a basic review of some algebra skills. And what we have here is some basic adding and subtracting of positive and negative numbers. Again, this is just some early stuff in the year that we can use to get some rust off of our gears in our brain. And let's take a look at this one, -8 minus plus 6. I've got a suggestion here for those. Some people can do this right in their head, and that's fine. But a suggestion I have for some folks is that you might want to split these problems or look at these problems a little bit differently. That's not the world's best 6. How about that? And look at it like this, that this is your starting point. This is the direction you're going, and this is how many units. So if you were to start off at -8, go to the right 6 units, you would land at -2 on the number line. Let's take a look at a quick number line here. Nice and cheap and easy here. So if we did start off at, let's just say -8, and we went 6 spots to the right, 1, 2, 3, 4, 5, 6, we would have landed at +2. 0 would have been somewhere around here. So I think this is a great way to start thinking about these positive and negative numbers in case you forget any of the properties or any of the rules. Let's take a look at another one. Where's this one here? Let's take a look at one with the fractions. How about, let's just do number 5. 7 3/4 plus -8 1/2. Again, maybe make that negative. So one thing we can do is go ahead and work on the whole numbers first, here and here, and have -1, and then have 3/4 minus 1/2, and see what we're left with. Some people like to go ahead and just convert this to improper fractions. So to do that, remember you're going to go ahead and multiply here. Four and 7, and then add 3 to it. 4 times 7 is 28, plus 3, 31/4. And add that to 2 times -8. Let's get the negative out of that. So 2 times 8 is 16, plus 1 is 17. Keep the sign. -17 halves. Now, since these don't have the same denominators, we can just go ahead and double this 2 to get to 4. Whatever you do to the bottom, you've got to do to the top. So really, we're going to have 31/4 minus 34/4. Again, all we did was just double the 2 and double the 17. Subtract these, keep your denominator. 31 minus 34, -3. I know what you're thinking. Isn't it easier just to go ahead and use a calculator? Well, it is easier to use a calculator. However, that's not what we're here for. We're here to get the rust off your gears in your brain, not the rust off the gears in your calculator. So let's take a look at some other ones here. Follow me down here. Let's take a look at number 10, 61 minus -11. Now remember the property that if you're subtracting a negative, then it's going to become positive. And we start off with 61 going to the right, 11 spaces, and we're at 72. Let's take a look at number 11. -16 minus -25. I'm still getting used to the mouse pad here, so I think later on in the year I will get better someday. let's simplify this one. Since we're subtracting a negative, we're going to go ahead and make that a plus. And then start off here. We're at negative 16, going to the right, 25 spaces. So we're going to have positive 9. So let's take a look at one of these other fractions here. Let's do number 16, 5 halves, minus 13 fourths. And there's something called the butterfly method that I'm going to show you guys. Hopefully this will make a little sense for some folks. The butterfly method is that we're going to go ahead and create like a little butterfly here. I know it sounds corny, but it actually works. And we're going to have a little bit of a butterfly butt right here, and we're going to have some antennae. So we're going to keep the sign. So here we go. Here's butterfly method. 4 times 5 is 20. 2 times 13 is 26. 2 times 4 is 8. So we're going to have 20 minus 26 all over 8. And that's going to be negative 6/8. And that reduces. These are both even, so we can go ahead and reduce those. 2 goes into 6 3 times, and 2 goes into 8 4 times. Okay, I just wanted to go back over that idea of the butterfly method. If I can go ahead and get this screen down. Let's take this here. Okay. Here is an example, 3 examples actually, of the butterfly method, where we have 3/4 plus 2/5. We draw our little wings here, our antennae, and 4 times 2 is 8, 5 times 3 is 15, and then the bottom here is 20, and then you keep the top and the sign, add those two together, 23, keep the bottom, and then what they did here was they converted that to a mixed number. The next one here, 3/4 minus 2/5, same thing, put the wings, butterfly butt, antenna, and they went ahead and subtracted these two. 15 minus 8, 7, and the bottom here, the denominator is going to be 7/20. This butterfly method is, like I said before, awfully corny, but it works every time. I'd also like to show you one more subtraction of mixed numbers. On number 15, I went ahead and just looked at the whole numbers. We talked about this briefly earlier. 2 minus 7, 2 minus 7 is 5, and then 2/3 minus 1/3. 2/3 minus 1/3 is 1/3. Then combine these, negative 5 and 1/3 is going to simplify to 4 2/3. Here, we did the same thing, but we converted these to improper fractions. Lucky for us, they had the same denominator, so we just subtracted straight across. 8 minus 22, 14, 3 and 3. Again, you just keep the denominator, and then you also keep your sign. Simplify this improper fraction to a mixed number, and you've got the same answer of negative 4 2/3. Okay, let's go ahead and talk about multiplication and division of positive and negative numbers, or in other words, our sign numbers. Remember that when you're multiplying a negative times a positive, it becomes negative. When you have a negative times a negative, that's going to become positive, remember. We don't write that because we assume all numbers are positive unless we have a negative out front. Same thing here for the division. Negative divided by a positive is going to be negative, and same thing here, negative divided by positive is also going to be negative. So let's take a look at these. We're going to have 2.1 times 3.5, and that's going to be a positive. So here we go. 2.1 times 3.5. And I know some of you have used the lattice technique. I might be considered old school, but bear with me here. 5 times 1 is 5, times 2 is 10. Space saver, 3 times 1, 3 times 2. Add. Count how many decimal spaces. We had 2, so our answer is going to be 735. Division is same thing. It's multiplication, but what you're doing is multiplying by the reciprocal of your denominator. So that's important to keep in mind. With that being said, we're going to have 2/3 times 1/4. How do we multiply fractions? Straight across. So you're going to have -2/12, and that's going to simplify since both these are even. Cut them in half to -1/6. Same thing over here. You're going to have 3/8. That was kind of a bad 3 there. -3/8 times the reciprocal here. In other words, flip that. 8/6. Multiply this through. -24/40. These are both even. Cut them in half. They're both even. Cut them in half. They're both even. Cut them in half. I know you probably could have used maybe 4 here as a divisor, or 8 as a divisor to trim those down, but sometimes people don't think about that, and they just would like to go ahead and use a real basic method. If they're both even, just keep cutting them in half until you reached a non-simplifiable fraction. The last thing I'm going to go over is some multi-operational expressions. And let's take the first one here, number 21. So here we go. Let's take the order of operations. The next one here, let's go ahead and take a look at 23. Again, we're going to use the order of operations. We're going to deal with the exponent first, and then we can go ahead and combine these two. -54 plus 126, that's going to be positive 0.72. And 1 divided by 4 is 1/4, otherwise known as 0.25, plus 0.72. And just like money, these decimals make a lot more sense to me if I just think about money. 72 cents and 25 cents, that's going to be 77, and then 97 total cents. Thanks very much for listening today for these basic review instructions, and look forward to seeing you guys tomorrow in class. Thank you.